Ismail. Ismail. Ismail, hello, welcome.
Thank you, Mr. Joseph.
Okay, you are the only one. Okay. I see another participant here. So far, we are only two. How are you?
I'm fine, thank you, sir.
Okay. Did you have a class very early in the morning today?
Yes, we had a class very early in the morning.
By Dr. Akech.
Yes, sir.
Okay. What about Professor Bruno?
Professor Bruno sent us an apology that he wouldn't make it this
Okay.
weekend, but he sent us some notes.
Okay. Oh, where are then your colleagues?
Let me try to reach out to them by calling them.
Oh. You think a WhatsApp would not do?
I'm going to do that as well.
Hmm?
Let me do that.
Okay, I will pause this. I'll pause this as I wait.
Okay, sir.
Hmm. Now I can share my slides. Okay. I have to be sure that if there's a possibility to record, that everything is recorded. I don't want to take chances. I want to be sure that if the recording is there, it is there. Okay. Research design. I would like to appreciate three members. Solomon is not here. Solomon is the man called Serge. Solomon, Ismail.
Solomon is called Arjuna.
Arjuna.
Sanjay is Vincent.
Oh, Arjuna is also absent today. Arjuna is absent.
Arjuna is around, sir.
Oh.
I'm around,
okay.
Doctor.
Okay. Yeah. Last week, I told you to put something on paper about your research direction, however vague, but only 3 people managed to send something, and I've given them feedback. So now you people who have not sent anything, you will not get feedback, because you only learn when you make some mistakes, and learning is by doing. So those who have not put down something, you need to learn to put down something and then you share. But also don't do the things in a hurry when such that it doesn't make sense. Okay? Now that we are proceeding with research design, you have to be very attentive as well to see where your thinking would fit. Because the purpose of getting you engaged from the beginning is to help you to follow, be in synchrony with the lectures, as well as try to understand what you're doing, comparing and contrasting. So if you don't have a topic, if you don't have a problem area, if you don't have anything you're thinking about, you will not be able to progress very well. Okay, so people who have given comments, they will work on them and send it back again, and then we'll see how we progress. So research design. What is research design? Okay. Research design is a strategy, overall strategy that you choose to integrate the different components of your study. Okay? It is a design, it is an overall strategy that helps to bring the different components of your study in a coherent and logical manner, thereby ensuring that you effectively address the research problem. And there's a point which says that the research problem defines the type of design you can use. Okay, you see the link. The research problem determines the type of design. So not every design is suitable for a particular problem. Not every design is suitable. Just like there are tools for every kind of problem, even for research problems, there are different tools. A design is like a tool that you can use to understand the problem. If you want to nail something, either on the wall or on timber, you might not use your hand because your hand may not be appropriate for hitting a nail. I mean, through a piece of wood or even a wall. So the nature of the problem determines what design you use. Other people define a strategy as a framework for the research action. The framework, the design, some people call it a blueprint. A blueprint. Just like when you want to construct a house, you might need a blueprint, a plan that you'll use to construct your house. If you start a house without a plan, you suffer. You'll suffer a lot because you will not know how much you need to construct the house. You will not know how much materials you need. You'll be gambling unless you have endless amount of money. Then you can construct. But when you start constructing and your friends or your wife or whatever comes around and say, no, I don't like this. I don't like this. The way this house is, I don't like it. So what will you do? So you break it down and start again. That's why you need a blueprint for construction, a plan, which helps you then to navigate your construction all the way through. Even the roof is normally planned. What nature of roof do you want? So if you look at the three-dimensional drawing of a plan, then you know the kind of roof you're going to have, even before you have it. That is the same with a research design. It helps you to see the end from the beginning. So you can already see where you are going with your research and what results you're likely to get when you have a research design. So some people just say it is a master plan that specifies the methods and procedures for your study. Master plan. Okay? So that is what a research design is. If you can't remember anything, just remember it is a plan. Remember it is a strategy. Remember it is a blueprint that will help you to navigate through your research process up to the end. Some students have a problem. They want to use all kinds of research designs in one study. If you see a student struggling to bring all kinds of research designs in a student's methodology, then you know this person doesn't understand what he's doing. He doesn't know what he wants, he doesn't know where he's going. Because like picking, some routes are going to Nagongera, some routes are going to Tororo. So now if you just pick so many routes, where are you going? So you have to be careful that you pick a strategy that will take you where you are going, given the nature of the problem you have. I hope that is clear. Now, what does a sound research design look like? Okay. So the length and the complexity of a research design can vary, but a sound research will have the following. Just like houses, okay? If you have little money, you draw a simple plan. If you have a lot of money, you draw a complex plan. Because your money determines the nature of your plan as well. Just like the problem you have determines the nature of the design. So the amount of money you have determines the plan, the type of plan you have. You cannot start saying, I want a storage block. I want a storage block when you don't have the money. Okay? So the length and the complexity of your research design will depend on the following. One, the research problem. And that's what I was telling Jemima. What is your research problem? That is the first thing you want to study. What is the research problem? And for those who were here last week, I was telling you that what is that bothers you that you want to investigate? Don't start something speculative. Start from something that you know is bothering you. You've seen it over and over. You really get bothered with it. You want to find its details and, if possible, contribute to its solution. All right? So if you're working and you see a problem, it would be good to start with that and then see how you progress, because that is what we call action research, or that's what we call applied research, where you get a problem, understand it in its entirety, you try to, after understanding it, then you can propose solutions. So the research problem must be clearly identified, and you have to justify why you have picked that problem. Secondly, the design will depend on review of previous literature associated with the problem area. You can never do a good study unless you have a good previous study review, because you are not an island. You're not an island, so you have to put your study in context. What are the people before me? What have they done? And actually, for your information, one of the good study problems would be one involving the gap that you discover in your literature review. When you study several researches and you come across a gap, that gap forms the basis for your problem study. That's why you can study without going to the field. You can actually collect studies that have already been published, and then you analyze them, and then the gaps that you find in those studies can form the basis of your new problem of study. So I've searched 300 literature. I've searched 50 literature in this particular topic. I have discovered none of these people have handled this problem. None of these people have used this particular methodology. So the gap is here. The problem is not handled, this particular problem is not handled. This particular methodology has been ignored. So you can start from there. So don't always think about, I want to do my study in the field. You can also do your study using published literature. All right? Thirdly, the research design must clearly and explicitly specify the hypothesis or research questions. If you cannot specify your hypothesis, then you haven't got it correct clearly. If you cannot state your research questions, then you are not clear where you're going. The good news is that once your problems are clearly identified and defined, the objectives come almost automatically. The objectives and research questions are related. Hypotheses are also related to objectives and to research questions. So don't be bothered about these terminologies. Hypotheses, research questions, research objectives, they are similar. It's just a matter of phrasing them. They have different phraseology. They are phrased slightly different, but the content is the same. So you must have it specified. Hypotheses, objectives, we normally call it specific objectives, and the research questions. That must be clearly defined. Then we continue the fourth point. It must effectively describe the data which will be necessary for the adequate test of the hypothesis and explain how such data will be obtained. So your research design must go ahead to describe what kind of data will be necessary for this kind of hypothesis. So you can see it goes chronologically. It starts with what is the problem? And what is the problem? And what are the research questions that you want to investigate? And now it goes ahead. What kind of data are you likely to collect? And is that data necessary or adequate to test the kind of hypothesis or the research questions you have? So you have to be able to project that as well. Because as I said before, it is a blueprint that helps you to see the end from the beginning. Sometimes I get excited when I see a 4-dimensional drawing of a house. It looks like a real house. It looks like it is already there, but it is not yet there. So the builders will use that to construct what is on paper. So you will also use your blueprint, the so-called research design, to get to the end of your research. What results am I likely to get when I use this? When I go through this route? The route is your blueprint called research design. So number 5 says you have to describe the methods of analysis which will be applied to the data in determining whether or not the hypotheses are true or false. So data analysis is very, very important. Later on, we will see if you are using quantitative methods, if your study is quantitative, then the methods of data analysis are also quantitative. If you are qualitative, if your study is qualitative, then your methods of data analysis must also be qualitative. So it's important to know that. Some people say, well, I'm going to do a mixed methods. I'll do both quantitative and qualitative. Granted, no problem. But you must be able to describe how will you analyze it quantitatively? And how will you analyze your data qualitatively? This is where people begin to talk about, I'll use correlational analysis. And correlation only works with quantitative data. And now we use regression analysis. Regression analysis. Regression only works for quantitative data. Some people say, I will use hierarchical regression. Hierarchical regression. That one also goes only for quantitative data. So the data must be in digits. The data you collect must be in digits, numerical. The 1, 2, 3, 5, 8, 10, 20, 30, 40, 50. Those are the kind of data you can correlate. That's the kind of data you can regress, and so on and so on. So you have to describe methods of data analysis to be able to answer those hypotheses, whether to prove them true or false. So we have now looked at what is a condition for a good research design. What are the conditions for a good research design? What must a good research design contain? And people who have already put down something on paper, you might begin to think, oh God, what is my research design? And so on and so on. But now we are moving on. We are going to see the two broad types of research designs in detail, the quantitative and the qualitative. We are going to get into that. Just checking in case I've gone off air. Because you can talk to yourself when you're off air. Are you following me?
Yes, sir, we can hear you.
Okay.
Yeah.
Beautiful. But also be prepared to ask questions. Okay, so now we move. This is a drawing that puts together quantitative research designs. I remember asking you people to draw a conceptual framework, and none of you, well, one person drew. Was that Solomon? Oh, was it Solomon who drew some kind of conceptual framework? A conceptual framework is basically a set of boxes, like you've seen there. A set of boxes. On the which hand is it? On the right hand side, you have the dependent variable. Like maybe if you are dealing with motivation, it becomes a dependent variable. There are ways. Motivation can also be an independent variable. But if you are looking at working condition and motivation, working conditions becomes something like independent variable, and then motivation is what is influenced by the working condition, something like that. Or sometimes people say, okay, what about remuneration? Doesn't it influence motivation? So there are various, so on the right-hand side, at the extreme end, you have dependent variable, and at the extreme left, you have independent. Now, most often the boxes for independent variables are more than one, because we normally we want to find which factors influence what we observe. What factors? So if you are studying one factor, you are limited. But if you're studying 2 or 3 factors, you are kind of trying to kill. You're trying to find out really what is the problem. It's normally advisable to have more than one independent variable. because it helps you to widen the understanding. So at the extreme left, I would expect 3 or so boxes. And the extreme right, I would expect 1 box. I saw one person giving me 3 or 4 boxes for dependent variable. Now that would be complicated. You cannot have many independent variables and many dependent variables. That kind of study is very complicated. So in the middle, we normally have what we call intervening variables. Sometimes we have what we call moderating variables. Sometimes we have the terminologies are intervening, moderating, mediating. We normally use those. They are similar in some ways. Moderating, intervening, mediating. So in the middle, we have that. I am just trying to recapitulate what we were supposed to do, but I have used the boxes here for something slightly different. These boxes are a good overview of something which is very complex. Okay? Now, that is the beauty of a conceptual framework. In one flash, you can see the relationship of very many things. So I encourage students always to think in terms of conceptual framework so that they bring all their variables together on one page or half a page. And then they can be able to describe them later. Okay, now quantitative research design is broken into 3 different, well, so far we are only dealing here with 3 different categories. Experimental design,
the host. Who else is the host?
sorry about that. My network decided to bully. It was doing some kind of bullying.
Sorry.
I think even my slide has to be shared afresh. When the network goes off, even the slide goes off. I have to share the slide again. I have to share the slide afresh. All right. Technology. So I'm back. And so I am here. I was just saying quantitative methods can be divided into three big divisions: experimental design, then the quasi-experimental design, and then the non-experimental design. Okay? So these are the three main divisions of a quantitative research design: experimental, quasi-experimental, and the non-experimental. Most times, most students do this one. Most studies and most students do non-experimental design. And that's the design which is also divided into three: the descriptive design, then the correlational design, and then the predictive design. So most of you might do your studies using non-experimental design. Either you are going to just describe the phenomena. If you are describing phenomena without explaining what causes what, you're just describing, you use a descriptive design. My purpose is just to describe the phenomena. How does it manifest? Sometimes you use descriptive statistics. This descriptive statistics is basically telling frequency, abuse of alcohol. How many times does this appear in my population? Abuse of funds. How many times does this appear in my population? Abuse of gender. How many times does it appear in my population? That is descriptive. So with that kind of statistics, you can be able to describe the nature of the phenomena. So that is descriptive. Normally, a descriptive design does not explain why. Why do you see this kind of abuse? Why? It only goes to describe. If you went to the market, you only take note of what you see. That is descriptive. Take note of what you see. Don't ask why. Why do I see this? Why? Don't just go and take notes. Count. How many are selling pineapples? 25. How many are selling potatoes? 100. How many are selling green vegetables? 50. How many are selling? That is descriptive. So when you go home, you can be able to say, in this market, these are the nature of the goods, and they rank like this. The most common commodity in this market is this, because it had the highest number of tallies, frequencies, followed by, like that. That is descriptive study design. You are only going to observe and record. You're only going to inquire and record. Do you go to school? Yes. Do you go to school? Yes. What kind of school do you go to? That is all. You take note of that, and then you can describe the results. Then you also have correlational design. Correlation design is also about numerals. The data you collect must be numeric data. The data you collect must be numeric data. So when you have data for independent variable and data for dependent variable, you can correlate that using either SPSS or using Stata or using any other software used for data. Even Excel can do the correlation. So just need two data sets, the data set for the independent variable and the data set for the dependent variable. Then you can be able to correlate. If you just want to do correlation, see the relationship between sales volume and advertising. Then you collect data on amount of money used in advertising. You collect them every month, every week, whatever you choose. Collect that money used for advertising every month over the years. And then you look at the sales that happen every month. When you correlate the amount spent on advertising with the amount of sales, then you can be able to say there's a relationship, there's a correlation between amount spent on advertising and the amount of sales or the volume of sales. That is important. So that would be correlational design. That's quantitative. And predictive design is about, as the name suggests, you are going beyond what you can see, predicting ahead of time. So you analyze something, but be able to go beyond to predict if this is moving in this direction. I project in 5 years, this is what I observe. If this is moving in this direction, in 5 years, this is what I project. People do that even in on their Vision 2020 or Vision 2030 or Vision what. They kind of project, they predict. They don't have it, they don't have everything there, but they predict. They say the way we are moving, in 2040, we shall be somewhere. That is a predictive design. Okay, now we can also go into details as we look at each of those. Now, I will start with experimental design. Now, I should have given you some kind of overview about experimental design, but this detail can also give you the same. Experimental design is used where the time is involved. There is a cause which precedes an effect in a causal relationship. There is a cause, and that cause happens before an effect in a causal relationship. In microfinance, we assume that if you give somebody money, that money will increase somebody's income, welfare. When you give somebody money to invest, that person's income and welfare will increase. So money that you use for investment comes first, and then after 1 or 2, 3 years, the welfare increases. That is a cause-effect relationship. That is a cause-effect relationship. One thing happens before the other. Some people say that the more degrees you have, the higher money you can get. Sometimes it's not true, but you can do a study on that. So, but before you know whether you get more money or not, you have to first have the education for cases where education has a relationship with welfare or property or riches. One thing happens before
Doctor,
Yes.
I'm sorry for interjecting. I'd raised my hand, but I think you were not seeing it.
Sorry.
I
Go
needed
ahead.
you to, yeah, I needed you to assist and kindly go back on experimental design where you started. I kind of lost it there when you started explaining.
Who is that talking?
This is Pauline.
Pauline. Okay.
Yes.
Experimental design, by the way, it is more scientific than social sciences, but it is also done in social sciences. McHugh business is a social science. Experimental design has its origin in the natural sciences. Okay? The issue is, I'm now going far backward, so to give you a picture, a bigger picture. In natural sciences, if you want to know whether quinine cures malaria, I am talking about history. If you want to know whether quinine cures malaria, you pick people at random. For example, those who have malaria. Then you divide the group. If you got a group of 100 people who have malaria, you divide them into two. One group, you give them quinine. The other group, you give them something which is not quinine, but you can concoct some very bitter stuff also and give it to them, because they will ask, what you're having, is it bitter? And then you will ask the other side, what about what you're having? Is it also bitter? Because when you don't want them to know that they are having different things. This is an experiment. So you give them, this one you give them quinine, the other side you give them something different. Let me say you cut a banana and you pick the middle stem of the banana, you crush it and boil it, and then you get also some bitter stuff, which is similar to quinine. Then you give it to the other 50. Then this one you give quinine. After about 3 weeks or so, you come back and test. The guys who had quinine, have they cured? What about the guys who had some banana juice somewhere? Have they also cured? So if the other group with quinine cured and the other group have not cured, then you know that quinine cures malaria. Okay? So that is experimental design. That is experimental design. Now I went back to say that experimental design is used where time is involved. That there is a time difference between a cause of something and the effect of something. Okay? So, a cause precedes the effect. When you do one thing, you will get the other thing. But you must first do one thing before you get it. Just like you have to first give treatment before you get the healing. Okay? You must first do the treatment because you can't have both the healing and the treatment concurrently taking place. You have just started a dose. Assume you just gave a dose today, and then you are testing for whether the person is cured. That is not. So there must be a time difference between the cause and the effect. And here, cause really means the intervention. The intervention. What is it that you are doing to handle the effect? I am giving them malaria queen. And then after some time, malaria queen will work in them and deal with those viruses, with those, whatever they are called, with those parasites. Until after some time, maybe 2 days, you'll find malaria has gone. So the time can be 2 days, it can be 3 weeks, it can be half a year. Pauline, are you okay?
Yes, I am okay.
Okay, now, secondly,
Doctor,
Yes.
I wanted to also ask whether my thinking is right. Because since I'm from a scientific kind of background,
Yes.
we usually, in this case, what we call these clinical trials, what
Yes.
we're actually trying to explain.
Okay.
And they're either blinded or double blinded or single blinded.
Double
However, in
blinded or
this,
single blinded.
yes, however, in this case, I was thinking of a business
Mm.
whose sales you can determine before it actually advertises, and then you compare it to after it has started advertising
Mm.
itself.
Mm.
Am I correct?
Well, what you're saying is what we call the baseline. There's what we call a baseline. Before I advertise, what was the sales volume? Okay. Now that I have advertised, is there a difference between what was there before and what I have now? Now, that difference is important to first know where you were before advertising. That's what we call
Yes.
baseline.
Yes.
So a baseline study is also very important in research because sometimes you might think that what you have, the intervention you have done is the one which has caused the difference. But you did not know that
Yes.
there was already something. Okay?
Yes.
So if that is possible also in natural sciences, you can do that. But you see, even what I was saying,
Yes.
if you gave that person mululuza,
Yes.
if you gave that other group mululuza, they might all be cured. Then you will be
True.
confused.
Yes.
Eh?
Yes.
Because malaria queen and mululuza might all be treating malaria, but you did not know. You get me?
Yes. Yes.
You thought you are giving them a placebo, and yet you are also giving them a treatment.
Treatment.
So you must know, you must have some baseline before you go ahead to do your experiment.
Okay.
Well, thank you for bringing that because, as I told you, keep thinking along with me as I talk so that you can bring examples and try to relate what we are talking about, whether there is some relationship between what we are talking about and what we are facing in the practice or what we observe in the field. Okay? So double-blinded and single-blinded, we will follow that later when we Google. But it is important to have you in class to help us with the experimental design. So we will come to what we call randomizing as well. Randomizing, and is really a terminology we normally use a lot in sciences, natural sciences. Randomizing. You pick the people at random. If you pick people who look ill and you compare with people who are not ill, then you have not randomized. You know, you have not randomized. Everybody must be same, and then you separate them. One group gets this treatment, the other group gets a placebo. Now, Ismail will later on explain to his colleagues what is a placebo. If he has no time, you will check what a placebo is in Google. All right, so now the second point there was that there is a consistency in a causal relationship, that a cause will always lead to the same effect. Now, that, of course, is good in natural sciences. We have sometimes problems in social sciences because the human being that we study, even in a business relationship, is not predictable. It is not very predictable. But in research, you try as much as possible to create similarity or something that when you find a difference, you say this difference has been caused by this particular independent variable. I don't doubt it. That's why when we're talking about research design, you must think ahead of time. If I do this, won't I get mixed results? If I mix up this methodology, might I not confuse the results? Why don't I just pursue this methodology and see whether I will not be very consistent? And when the results come out, I am sure that it is this, not something else, that has caused it. Okay? All right, so there's consistency in the causal relationship, that a cause will always lead to the same effect. And that's why we do repeated experimentation. You try the first time, you get the results. You try again, you get the results. When you try the third time, you can be sure that it is the same. I miss my chemistry and biology. I miss particularly chemistry. I abandoned it very many years ago, but I used to enjoy going to the lab and trying to do experiment. If you add this acid over to something, you add this chemical to the other chemical and you see the chemical reaction. If you do that all the time, you expect similar results. That's what we mean by consistency. If you do it and you get different results, you know there's a problem. What is wrong? Okay? So you can also say, number 3, that the magnitude of the correlation is great. There must be a correlation. Otherwise, what kind of experiment are you studying? What are you looking for if there's no correlation? So there must be some correlation. Just like I said, malaria queen. I am malaria queen? Oh, did I talk about quinine? I am mixing them up. But whatever the case, you must have some idea that malaria queen has an impact on malaria. Okay? If you want to deal with coronavirus, that one, maybe that would be the better example. Coronavirus. I don't know, I have never got the dose of the vaccine for coronavirus. None of us, even the big men, have been denying that they have ever got it. But you don't know whether those vaccines have a relationship with the healing or with the protection. I haven't done the correlation. But for you to go into that experiment, you must first do some background test to see whether there is a correlation between the vaccine and the protection. Okay? So the experimental group, what we call classic experimental design, specifies an experimental group and a control group. You must have an experimental group, the first 50 who got malaria queen, and the control group is the other 50 who got banana juice mixed with kamulali. So whether the banana juice mixed with kamulali will also treat malaria, you don't know, but at least it might not. Okay. So we continue with the experimental design. The independent variable is administered to the experimental group and not to the control group. And both groups are measured on the same dependent variable. They are both sick of malaria. That is the dependent variable. All the 100 patients have malaria. The 50 is given malaria queen. The other 50 is not. The control group is not given malaria queen. That's what we are saying. The independent variable, which is malaria queen, is administered to the experimental group and not to the control group. And then both groups are measured on the same dependent variable. Do they cure of malaria? That is a condition for experimental design. Now, for people who are thinking business, I had started this example before. If you give me credit, call it microloan. Talk about baseline. I and Ishmael have everything the same. Our everything is the same. Talk about income, talk about welfare, talk about education, talk about intelligence, talk about, we are all the same, I and Ismail. Now I get a credit, call it microloan. Ishmael does not. After I have used my microcredit to do some business, and Ishmael does not do any business, after 1, 2, 3 years, if you compare me with Ishmael, are we the same? Are we the same? Of course, I may have beaten Ishmael, but Ishmael also may have done something else which I did not do. And you might find Ishmael beating me. But that is why in experimental design, you must control. You have to surveil Ishmael to make sure that he doesn't do anything else that will increase his welfare. That's when you can know that the microcredit you gave me is the one that has made me better than Ishmael. Are you following that, members? But in the real world, you cannot surveil Ishmael, okay? You can't. That's why it's difficult to do an experimental study in social sciences, because you cannot put Ishmael in the lab and keep him there until you are finished experimenting with the world. Can you? Not at all. But as we continue to study, you'll discover that you can prepare your design in such a way that you can do an experiment in social sciences. With a lot of conditions, you can be able to do an experiment in social sciences. Some people do that in psychology a lot. Some people do that also in business a lot. So from the example I've just given you, you can think about experiments in business, in all sphere of business. Okay? If you are a farmer, then they add you more land, and then your friend is not added land. Do you think there will be a difference? So all kinds of things can be thought about. Okay, now another point is that the subsequent experimental designs have used more groups and more measurements over longer periods. So when you do experimental designs, keep growing the numbers. Keep growing the numbers. And finally, true experiment must have control, and there must be randomization, and there should be manipulation. You will notice that we have already talked about this. Control group, experimental group. The 50 given malaria queen is the experimental group. The 50 giving placebo, which was actually banana juice with camulali, that is the control group. Randomization is what I began with. All of them have malaria, and you pick them at random. You don't select. You don't select. Just pick them. This 50 here, that 50 there, and they're all the same. And then manipulation is actually the intervention. That is manipulation. That's the intervention. Oh, well, what does experimental design tell us? This is now, I'm going to go quickly over this. It allows the researcher to control the situation. And in so doing, it allows researchers to answer the question, what causes something to occur? It helps us to know the cause better than anything else. Secondly, it permits the researcher to identify cause and effect relationship between variables and to distinguish placebo effects from treatment effects. We have already talked about that. It supports the ability to limit alternative explanations and to infer direct causal relations in the study. Once you have done your experiments, it gives that support so that somebody cannot begin to say, but I think, but I guess, but I imagine, and so on. So that is limited. Experimental design helps you to support, to limit alternative explanation, because you have done the experiment and you've repeated it, and you've repeated it, and you've repeated it. So you have confidence to say, I know the cause, and you can be able to stand by it. And finally, I can say it provides the highest level of evidence for single studies. If you're doing a single study, experimental design will help you a lot. I will want to finish this part one of my research design.
Doctor, I have a question.
Yes. Go ahead.
What is a single study?
A single study. There are people who do multiple studies. Multiple studies.
Okay, so poor.
Pardon? Multiple studies, you're doing so many.
I can hardly hear you.
Oh, am I not visible anymore? Let me check.
Doctor, I can hear you.
Oh.
And I can even see you.
Yes, but now my colleague is not hearing me.
Yeah, we not see.
Why is my colleague not hearing me? The colleague was asking me, what is a single study? I wanted just to mention that there are people who try to do multiple studies at the same time. And so multiple studies can be complicated. If you have a single study like what I've just been describing with malaria, that would be a single study. But if you want to do the effect of malaria queen, and then you add on welfare of the people, then you add on school learning, ability to understand, and then you add on ability. If you're adding on many things, you might have it very complicated. So deal with one thing at a go, and then you'll have a single study. Multiple studies is complicated and will require multiple methods maybe, or multiple designs. Can we proceed? Or? Okay. So now I will take you to quasi-experimental design. Having gone very detailed on the experimental design, the quasi is just that some kind of an attempt to emulate experiment. Okay? It's half experiment. A half experiment. So it involves the manipulation of the independent variable without the random assignment of participants to conditions or orders of the condition. Okay? Because you are not able to do the randomization or random assignment, you are doing quasi. You're doing quasi experiment. Manipulation of the independent variable is there. Malaria queen is given properly, but then there's no random assignment. The members have not been randomly selected and also not randomly assigned to the group. That is very important. When we get to sampling and sampling techniques, the word random will come even more clearer. But we know the word random is a common word. You just pick at random? No. And so on and so on. We use that quite a lot. So random assignment, very important for experimental design. When it is not there, then it is not fully experimental. It is quasi-experimental. There's an example here. You can say that if you have non-equivalent groups, non-equivalent, one group has 50, another group has 30, that is already kind of, Now, you can go ahead to say that you hypothesize that a new after-school program will lead to higher grades. Okay? People have gone to school, they close at 4, and then you organize the after-school program. After 4, then you teach them. And then you know that this will do what? Bring better grades. Now, you choose 2 similar groups of children who attend different schools, one of which implements the new program while the other does not. Now, when you do that, you are doing quasi-experimental, and they are not equivalent. Okay? They are not equivalent. That's why we call it quasi-experimental. So these are studies that aim to evaluate interventions, but that do not use randomization. They are similar to random trials, but aim to demonstrate causality between an intervention and an outcome. They also try to do that effect. They want to try the cause-effect relationship, but then the rigor that is performed in experimental design is not followed in this quasi-experimental. Now, since I started already in details to describe the non-experimental design, even if I don't stay on this long, that will be okay. And you might actually be surprised. People like Jemima, who did some research before in their bachelor's, they might have heard about descriptive design, correlational design, or predictive design. They may or may not have heard, but at least those are common terminologies. Okay, and I started in details to explain what a descriptive design is. And then I also went ahead to explain what a correlational design is. And then I told you that people who are projecting that by 2040, we shall be a middle-income country, they are predicting. So if you also want to predict where you will be in 20 years, you can go ahead. Just study where you are, study what you're doing, and then you can be able to predict where you will be in 20 or 30 years, you as an individual. But also you as a business, you can be able to do that. Sometimes you might have to think about what model am I using to predict? What model am I going to use to predict? Okay, so I said this before, that in descriptive design, you don't have to answer the question, how, why, when. Those are not important. Just go to the market and take stock of the members selling matoke, people selling Irish potatoes, people selling pineapples, people selling fish. Count them and record them. Then come home and describe. That is descriptive study. Don't ask why they are selling matoke. Don't ask why they are selling tomatoes. Don't. That's not what you have gone to do. Your design is descriptive. Full stop. So descriptive research design precedes explanatory. Actually, when somebody has seen what you have described, he can go back to find out why. Now that becomes explanatory design. Why are there more sellers of matoke in this market? Why are there very few sellers of pineapple in this market? Why? The answer to that question is the explanatory design, because you're going beyond what you see into why you see what you see. So correlation, I also said that, and I think I even mentioned the example of, if you are expanding, if you are increasing your advertising expenditure, is it correlating with increase in sales? Of course, eventually with revenue. You are there busy increasing your advertising expenditure year to year or month to month. What happens to your sales revenue, or what happens to your sales turnover? Are they also correlating? Do you see a trend as you increase your advertising expenditure? Do you see a trend in increase in revenue? Do you see a trend in increase in turnover of sales? If there is, then you know that there is a positive correlation between expenditure on advertising and your sales volume, or sales or revenue. That is positive correlation. But there can be negative correlation as well. You increase your expenditure on advertising and you get a drop in sales revenue, or you get a drop in sales volume. That's a negative correlation. If you are wise, I think you would immediately stop spending on advertising, because you are losing. So there is negative correlation, there is a positive correlation, and there is no correlation at all. Get your data for advertising expenditure, get your data for sales volume over the years, correlate them, and you find R equals to 0. Then you say, I have no business here. Advertising has no correlation with sales volume, so I don't need to advertise. It's a waste of money. Okay? So that is what correlation does. That's what correlation does. Finally, predictive design. This is a design concerned with forecasting events, future events or behavior. So you assess the variables at one point in time so that you can predict a phenomena at some future point. Forecasting. If you see that our growth rate has been growing from 4 to 5 to 6 to 7, logically you will expect that growth rate to continue at that rate, logically. So you can actually project 10 years ahead, saying all things remaining constant, we expect our growth rate to reach 20% in year 2020, year 2040. Okay, that is predictive design. Example, a researcher might collect high school data such as grades or extracurricular activities or teacher evaluation or advanced courses taken or standardized test scores in order to predict college success. Okay? If you collect that data, you can be able to predict college success. Successful students are those that have gone through all this. They have done great, they're doing well in class, they have extracurricular activities, their teachers are doing fine, they are taking also advanced courses, and so on. They have also given them IQ tests and so on. So when you have all that data, you can be able to predict the performance of the student at graduation. You can be able to predict performance of the student at graduation. You can say, the way I see things here, this is a first-class student. I am studying the student in first year, but I project, if he's doing civil engineering, I project in 4 years, this student will be a first-class student. If he's a medical student, I project in 5 years, this student will be a first-class, although they don't grade degrees in medicine, but you can predict. So our next class will be on the qualitative research designs. We have tried as much as possible to emphasize quantitative research design today. Next time, God willing, we shall handle qualitative research design. Okay, this brings us to the end of today. If you have any questions or comments, you can do it now in the next 1, 2, 3, 4, 5, 6 minutes. Okay. George failed to join us completely. George failed to join us. Sarah also could not join us wherever she is. No, is it Sarah? Hannah could not join us. But we are happy to receive Ampere Jemima. Members, have you met Jemima?
So far, we have only managed to see her fix.
Pardon?
In the morning.
Ampere, were you there in the morning?
Yes, I was there in the morning.
Can you put on your video?
My front camera is having issues and I'm using my phone. So today I cannot.
You don't know where the video is?
Yes. No, my phone's camera is having issues. So I think maybe tomorrow when I'm using something else.
Tomorrow we are not here.
Oh, next week.
Okay. Okay, if there are no comments, I appreciate your intelligence. Is there a comment? Is there a comment?
Can I ask
Hey, your network.
some